In this video, I'm going to show you how to solve equations containing fractional and decimal coefficients. So first of all, we want to solve this equation 3/2 x plus 1 equals 4. Now remember, our goal here is to isolate x, get it completely alone on one side of the equation. And tools that we have at our disposal include the addition and multiplication principles. Remember, the addition principle says that we can add or subtract anything from both sides of the equation without changing the solution. And the multiplication principle says that we can multiply or divide both sides of the equation by any non-zero number without changing the solution. So what do you think? What should our first step be to isolate x on one side of the equation? Why don't we get rid of this 1 here? We can apply the addition principle to subtract 1 from both sides of the equation, and that'll cancel out that 1. And then we'll just have 3/2 x on its own side. And that'll be a step towards isolating x, getting it alone on its own side. So let's go ahead and do that. Apply the addition principle, subtract 1 from both sides, and the result is 3/2 x. That 1 minus 1 cancels, and then we've got equals 4 minus 1, which is 3. Alright, so we're closer to the solution. Now we've got 3/2 x on one side, and all that remains is to get rid of that 3/2 in front of the x. The addition principle isn't going to help us anymore here, but the multiplication principle will. First of all, we can cancel out this denominator in the fraction 3/2 by multiplying both sides by that denominator, 2. So we're going to go ahead and multiply both sides by 2, according to the multiplication principle, and the result is this times 2 will cancel that denominator of that fraction 3/2, and we'll just have 3x on the left side. And then on the right side, we'll have 3 times 2, which is 6. Now we just need to get rid of that 3 in front of the 6. And we can do so again using the multiplication principle, this time dividing both sides by 3. So we do that, and the result is 3 divided by 3, that cancels out, that's just 1. So we just have x on the left-hand side. Great, that's what we wanted. And then 6 divided by 3 on the right-hand side is 2. So there we go. There is our solution. X is equal to 2. On to the next problem. We want to solve this equation. A half equals 4x over 3 minus 3/2. Again, we want to isolate x on its own side. And again, we want to do this using the addition and multiplication principles. First of all, to get rid of this minus 3/2 on the right-hand side, we can use the addition principle and add 3/2 to both sides. So let's go ahead and do that. Plus 3/2 plus 3/2. So now, this minus 3/2 plus 3/2 cancels out, and on the right-hand side, we just have 4x over 3. And then on the left-hand side, we have 1/2 plus 3/2, which is 4/2. We can simplify this a bit. 4/2 is just 4 divided by 2, which is, well, just 2. So 2 is equal to 4x over 3. Okay, so we're closer to the solution now, but we still have this 4 and this over 3 along with the x, and we want to get rid of those numbers. First of all, to get rid of the 3, notice that 3 is just the denominator of a fraction, so we can get rid of it by multiplying both sides by it, the multiplication principle. Multiply both sides by 3, and the result of that, this times 3 will cancel with the denominator of that fraction, and we'll just have the numerator, 4x, on the right-hand side, and then on the left-hand side, we have 2 times 3, which is 6. Now we just need to get that 4 off of the x, and we can do that with the multiplication principle. We just divide by 4. Do that to both sides, so that we're not changing the solution at all. And the result, this 4 divided by 4 cancels, and we just have x on the right-hand side. And then on the left-hand side, we have 6 divided by 4. Why don't we write that as a fraction? 6 over 4. We can reduce this fraction a bit. Both 6 and 4 are even numbers, so they can be divided by 2. So if we divide by 2 on top and bottom of this fraction, we just get 3 over 2. And that's simplest form of the fraction. So 3/2 is equal to x, and that is our solution. Now we've got some decimal equations, and in the first one, we want to solve the equation 2 plus 0.3x equals negative 0.1. Our method for doing this is going to be very similar to the method in the previous problems. We're just going to apply the addition and multiplication principles. First of all, to get rid of this 2 on the left-hand side that accompanies the 0.3x, we can just apply the addition principle and subtract 2 from both sides. That'll cancel out the 2. So we'll go ahead and do that. The result is that the 2 cancels with the negative 2, and we just have 0.3x on the left-hand side, and that's equal to negative 0.1 minus 2. You can also interpret this as negative 0.1 plus negative 2, and negative plus a negative is a negative, and the number that goes after the negative you get by just adding these two numbers, 0.1 and 2. 0.1 plus 2 is just 2.1. Alright, so now we just need to get rid of that 0.3 that's multiplying the x. And we can do so using the multiplication principle. We can just divide both sides by 0.3. The result of doing that is that the 0.3 on the x cancels with that divided 0.3, and then we just have x on the left-hand side, and then on the right-hand side we have negative 2.1 divided by 0.3. Why don't we just write that as a fraction for now? And this is a negative divided by a positive, so the overall result is going to be a negative. So negative the fraction 2.1 over 0.3. Now the fraction 2.1 over 0.3 is a little bit tricky to digest. So why don't we make it a bit simpler by eliminating the decimal place? The way we can do that is by multiplying the numerator and the denominator of the fraction by 10. So we multiply the fraction by 10 over 10. This way, we're not actually changing the value of the fraction, we're just writing an equivalent fraction. So when we do that, we get that x is equal to negative 2.1 times 10. Well, 10 just shifts the decimal place once over. So 2.1 times 10 is just 21. And then 0.3 times 10, just shift the decimal place once over, you get just 3. And 21 over 3, we know what that is. 21 divided by 3 is just 7. So x is equal to negative 7. On to the second question. We want to solve the equation negative 4 equals 1.2x plus 10. Negative 4 equals 1.2x minus 10. Again, we'll start off using the addition principle. We want to cancel out that minus 10 so that we can get this 1.2x alone. So we'll just go ahead and add 10 to both sides. When we do that, the minus 10 cancels with the add 10. It just gives us 0, so we don't include it. And then on the right-hand side, all we have left is 1.2x. Then on the left-hand side, we have negative 4 plus 10. You can also think of that as 10 minus 4, which is just 6. Alright, so now the only thing that remains is to get this 1.2 off of the x. We want x completely alone on its own side. And we can do that by dividing by 1.2, because 1.2 is multiplying x, and the opposite of that is division. So just use that multiplication principle, divide by 1.2 on both sides, and we get an equivalent equation, but that is solved for x. Alright, so this 1.2 cancels with the divided by 1.2, and on the right hand side all we have left is x, that's good. Then on the left hand side we have 6 divided by 1.2, let's just write that as a fraction for now. 6 over 1.2. Now, in order to evaluate the fraction, we're going to do the same thing that we did before. We want to multiply the top and bottom of the fraction by some number to move over the decimal place, and that number would just be 10. So 10 times 6 and 10 times 1.2 multiply by the same amount on top and bottom, so we're not changing the fraction at all, just writing an equivalent fraction. So in the numerator, we have 10 times 6, which is 60, and then in the denominator, 10 times 1.2, multiplying by 10 just shifts that decimal place over a single time, so we've got 12 in the denominator. So 60 over 12 equals x, and hey, we know what 60 divided by 12 is, that's just 5. So x is equal to 5. So now we know how to solve equations containing fractional and decimal coefficients by applying the addition and multiplication principles. In the future, we'll continue to learn how to solve even trickier equations, including linear equations that have variables on both sides.